31 next permutation. It's a median Leetcode question, and it's basically give you a number array, and then it include a number. It asks you to find the next permutation based on the lexical order of these numbers. And for example, if you are giving an array and 1, 2, 3, right, and the followings are considered permutation of 1, 2, 3, 1, 3, 2, they all permutation, but you need to find the next permutation. Basically, the lexical order is greater than the current one. So for example, the next permutation of 1, 2, 3 is 1, 3, 2, and if 2, 3, 1 is 3, 1, 2. So the next permutation of 3, 2, 1 is 1, 2, 3, because 3, 2, 1 is already like the end, it's all in descending order. So when you try to find the next order, it's basically 1, 2, 3, because 3, 2, 1 does not have a lexical larger rearrangement. So you basically start from scratch and reset it. So the replacement but must be in place and use constant extra memory. So if it's 1, 2, 3, and you will have to return 1, 3, 2, and 3, 2, 1, you have to return 1, 2, 3 in this case, and 1, 1, 5, you have to return 1, 5, 1. And there's some constraints here, and the company asked this question. You will be surprised. So many companies asked this, especially Facebook asked this question 67 times in the last 6 months. So there is a trick. If you want to brute force it, it's very inefficient and you're not going to be able to pass. And there's a trick how you can do it. It's either you know the trick, you know how to do it, or you don't know the trick. And so first, you need to understand the next permutation of different number combination. Like if you have one, for example, like the 1, 2, 3, right? And then if you want to find the next permutation, you basically backtrack it. If you backtrack the 3, then you don't really have an option. You put the 3 back here, and you can't change anything to make the permutation different. So then you have to backtrack 2, and then when you have 2, then you can put it back. Since you already put 3 and it was 2 before, so you can put 3, and then in the end, the last position, you have no any other options. You have to put 2 here, and 1, 3 is 1, 3, 2 lexical order then bigger than 1, 2, 3. Yes, so then you find the next answer. Basically, 1, 3, 2 is a little bigger than 1, 2, 3, right? And then if you want to think about the we already did the 1, 2, 3. The next 1, 2, 3, and then the next permutation. So 1, 2, 3. Next permutation is 1, 3, 2, right? So what is the next permutation for 1, 3, 2? So you already did all the combo of like 1, 3, 2. You already did a 3 and 2 position. You basically backtrack it. In this case, you need to backtrack 1 as well, right? So you have to put the next one that is bigger than 1, which you only have 2 as an option here. And if you put 2, then you put, and the smallest is 1, right? Because it's lexical order, then 2, 1, 3. I'm just giving you examples so that you understand what's the next permutation here. So then what's 2, 1, 3's next permutation? So since you already put 2 here, right, and the 3 is bigger than 1, right? So then the next permutation is 2, 3, 1. So I think by now you have a better understanding of what next permutation is. Basically, you backtrack it and then you try to find the lexical order that meet that requirement. And I want to show you our example on how we can do this question and the trick how you can do it. Basically, 5, 3, 1, 1, 5, 8, 4, 7, 6, 6. 5, 3, 1. Let's using this example. So if they give you an example to ask you to figure out the answer what's the next permutation for this one? Basically, the trick is that you have two index I and j put in the end of the starting from the end of the array and keep going back. And what you do is, so j is in the end, right? And then you want to continue to shift I to a degree that the I minus 1 is not bigger than the I, and then you stop right there. So look at this, 3 is bigger than 1, 5 is bigger than 3, 6 is bigger than 5, 7 is still bigger than 6, and then we want to stop right here is because 4 is actually bigger, smaller than 7. So I'll place I here. So the trick is basically you find this position. So basically you go from the end of the array, the number keep getting bigger, and if it's smaller, you stop right there. And then you want to swap, not swapping yet. And basically the number 4 is I minus 1, right? If 7 is I, and then I know it's a bit tight here, then the I minus 1 is at the 4 position. What you wanted to do is, once you find this position, right, you're going to start move the j from the end. How, under what kind of circumstance you want to continue to move j? You want to move j when the j is, you want to compare j with I minus 1, because j with I minus 1 is the number that you want to swap in the end, and you continue to move j to compare these two numbers. If j is smaller than I minus 1, you want to continue to move j, decrease j to the left until j is bigger than I minus 1. Then you stop right there. So is 1 smaller than 4? Yeah. So we're going to move j to 3, right? 3 smaller than 4? Yes. And 5 smaller than 4? No. 5 is bigger than 4. So we stop j right there. Once you find this position, what you wanted to do is you want to swap this I minus 1 with j. So you want to swap the 4 with 5 here. Once you swap them, and you will do another step, is basically sorted the rest of the array. This is I minus 1, right? You basically wanted to reverse the rest array from reverse the everything on the starting from the I position. So the next permutation will become 1, 5, 8, 5, and then you reverse it, right? So it will become 1, 3, 4, 6, 7. Yep, that's basically what we're looking for. Originally, that by doing that, we have already swapped the 7, 6. Let me write the original 3, 1. So this is the original array that was given, and then this is, we swap the I minus 1 and j, and then once you swap them, you want to rearrange the array starting from the I position, basically reverse all of them, and then you can have the right answer. And this one will be the next permutation, and I'll prove it to you when we run the test case. And I'm going to show you how to do this in code here. So basically, you want to give I, j, they're basically starting from length of nums minus 1. That's the index. You want to remember, we put the I and j in the end of the array at the beginning, right? So what was the first step that we did? We keep decreasing I until a position that's the I minus 1 is not bigger than the I. So we stop right there. So basically, if I is bigger than 0 and nums I minus 1 is bigger or equals to nums I. So while the previous number is bigger than this, we're going to continue to decrease I, right? And then decrease I. Of course, there could be a scenario that the entire array only have 7, 6, 5, 3, 1. So just ignore this part. Let's only look at this part, 7, 6, 5, 3, 1. That's basically similar to the 3, 2, 1 situation, right? If the array is 3, 2, 1, the I is already at the right position. So we will reach a position that I becomes 0, right? In that case, if I equals to 0 at the beginning, right? We basically just nums reverse. We just need to reverse the number, and then we already find we're going to return, because in that case, we already find the next permutation once we reverse it. 3, 2, 1 to 1, 2, 3, right? That would be the perfect example. So another scenario is that we continue to move I is not reaching to the end, basically like this case here. And if not to the end, what we're going to do is that we're going to start shifting j, right? So basically, while nums j, and we're going to shift, j, we're going to shift the j to continue to shift the j if the j is smaller than I minus 1. Remember, that was the number that we were comparing, right, at the beginning. And if it's smaller than j, we're going to continue to decrease j to the left side. Once we get out of this while loop, meaning that the j is no longer smaller than I minus 1. So j, for example, like this case, 5 is bigger than the I minus 1. In that case, what we're going to do, we're going to swap 4 with 5, right? And then, so we're going to nums I minus 1, basically swap with nums j. And then that will be equals to nums j, nums I minus 1. So in that case, we have already swapped the I with j. Basically, we're already here. Once we did that, what we wanted to do is basically we want to starting from the I position and basically reverse the entire array. How do we do that? Is in Python is basically we want to start from the I position, and for the rest of the array, what we wanted to do is nums. We want to from the last position, length of nums minus 1. That position, not like this, but the first one is I minus 1 to from the end of the array to minus 1. And that's basically we'll swap until the I. And we want to do minus 1. That means starting from the end of the array, it will swap it. And in that case, after you swap you reverse the array from the I position, and then the entire array is reversed. And by doing this, you will get the next permutation. That's basically the trick. And let's run this. So you got the answer, right? And let's run this case. We can run this test case to prove that that is correct. Yep. So basically, that's the trick. So just to reiterate, all you need to do is just shift I to a non-descending order position first, and then you want to shift the j to a position that is slightly bigger than I minus 1, and then you want to swap I minus 1 with j. And once you swap them, you want to start reverse the rest array, starting including the I itself, starting from the I position. And then once you reverse it, you will get that's the next permutation for the current array. And let's submit. Yep. If you think this is helpful, please like my video and subscribe to my channel. And I'll see you soon with more Leetcode question. Bye bye.